So picking up where we left off, 1.5, completing the square. We have some steps. We'll walk through the steps and then we'll do a problem walking through those steps as well. So we want to solve ax squared plus bx plus c equal to 0. That's our standard form, general form. It says if a is not equal to 1, then divide both sides by a. In other words, we're going to divide each term by a if a is not equal to 1. All right. Then we're going to isolate c to one side of the equation. So in other words, when we look at what we have right here, we're going to take that term that does not, or the term that's not attached to a variable, we're going to take it to one side of the equation. So it'll be there by itself. Step 3, take half of b and square it. Then we're going to add that result to both sides of the equation. All right. Step 4, we're going to factor the perfect square trinomial and then simplify the other side. Step 5, solve using the square root property. And step 6, or the final step, is always to check if you desire to do so. All right, so if I scroll up too far, let me know. All right, first example we have here is x squared minus 6x plus 4 equal to 0. So remember, step 1 is if a is equal to 1. And so since a is equal to 1, remember, if you don't see anything, they assume you know there's a 1 sitting out front. So since a is equal to 1, there's nothing to do for step 1. Step 2 is to isolate the radical to one, not radical, isolate the constant to one side of the equation. So we have x squared minus 6x plus 4 equal to 0. So we're going to subtract 4 from both sides. 4 is canceled on the left. And then what we have here as a result is x squared minus 6x equal to negative 4. All right, any problems with that? Step 3. The first part of step 3 is to take your b term. B was negative 6. We're going to take half of that and square it. Half of negative 6 is negative 3. Then squaring that is 9. Then you add that to both sides of your equation. And that's where we are at the end of step 3. X squared minus 6x plus 9 equal to negative 4 plus 9. Step 4 is to factor that perfect square trinomial on the left and then simplify what's on the right. So if you ever have trouble with your factoring, we're talking about this right here, whatever half your b term was is what goes there. So notice half of negative 6 was negative 3. So that's why we have x minus 3 right here. So that's how it always works. If you ever have trouble with your factoring, then in the next one you'll see We will even be dealing with fractions. Whatever half of your b term was, whatever half your b term was or is, that's what will go in the factorization with your x. All right, and then of course -4 plus 9 is 5. All right, so now we can solve that by taking the square root of both sides. Square and square root cancel on the left. And that leaves me with x minus 3 equal to plus or minus square root of 5. So don't forget, square root property says that we use plus or minus whenever we take the square root of both sides. Then to finish it off, we'll add 3 to both sides. 3's cancel on the left. And that'll leave us with 3 plus or minus square root of 5. And don't forget, in my math lab, I don't believe they have a plus or minus symbol. So you write 3 plus square root of 5, 3 minus square root of 5. All right, questions, any questions? All right, let's do it again. So the next one, we have 9x squared minus 6x minus 4 equal to 0. This time a was equal to 9. So we divide each term by 9. Remember before we didn't do step A because a was equal to 1. If a is equal to anything but 1, you have to do step A. This time a was equal to 9, divide each term by a, and simplify. So the 9's cancel in front of x squared, which is what we need. Then 6 over 9 reduces to 2/3, and 4 over 9, can't reduce that, so that stays the same. 0 over 9 is 0. Excuse me. All right, step 2. We want to isolate our constant. So we're going to add 4/9 to both sides. So we have x squared minus 2/3 x equal to 4/9. All right. So let me erase something so we can walk through this. So now b is -2/3. So we take half of -2/3 and then square it. So half of -2/3, that 2 can cancel, leave you 1. So half of 2/3 is -1/3. Then -1/3 squared will be positive 1/9. So we add that 1/9 to both sides of our equation. X squared minus 2/3 x plus 1/9 equal to 4/9 plus 1/9. All right. So step 4, want to factor and simplify. So once again, half of my b term, that -1/3, is what goes in the parentheses with my x. So it's x minus 1/3 squared. Then 4/9 plus 1/9, 5/9. Square root property, want to solve for x. So I will take the square root of both sides. Square root cancel on the left, leave me with x minus 1/3. Then on the right, once again, plus or minus, don't forget it. X minus 1/3 equal to plus or minus square root of 5/9. So when you look at the square root of 5/9, you're going to simplify that. You would take the square root of both top and bottom individually. Square root of 5 can't reduce any without turning into a decimal, but the square root of 9 is 3. So we're looking at x minus 1/3 equal to plus or minus square root of 5/3. And to finish it off, we got plus 1/3 to both sides. And that's 1/3 plus or minus square root of 5/3. Or if you wanted to write it all together, since they have the same denominator, you can write 1 plus or minus square root of 5/3. Now remember, if they were imaginary and real, dealing with complex numbers, we would leave them separate. But this is all real, so it's okay to bring them together or to write them as a whole term. All right, questions? Any questions?
Yes, I have a question. What would you do with that answer? How would that answer be applicable to something else that you're trying to solve?
Well, that's actually a representation. Like, that's the exact form of it. But if you were to put that in a calculator, it's actually just a decimal. So if, not saying this answer, if it's 1.59, then, you would take that in whatever way you're using it. If you're doing it, compare data values or whatever. Or since this is a solution, so it's a solution to whatever it is you're trying to solve, whether it be, there's an arc and you're trying to figure out where they connect that.
Sure. No, that makes sense. I've just never seen somebody hand me an answer in any real life situation where the answer is, 1 plus or minus square root of 5/3. But I've had people say the answer is 1.5. That's the only reason I was asking.
Yeah. So this is what will happen here. What this does, because square root of 5 puts you in a position of having a run-on decimal to infinity. What this does is it gives, let's say if I came and solved down for this, I could give you, like let's say if it represents 1.5, I can give you 1.59. But if I give you this answer, it leaves you the opportunity to be as exact as you want. So if you want to go past 2 decimals, you can. Or if you want to go all the way and go to 5 decimals, or if you want to go out to 100 decimals using the computer and do data crunching, you can. But if I gave you 1.59, you no longer have that option.
Nice. Okay, that makes sense. Cool.
Yep. All right, great question. Any questions on that last method, the third method, before we look at our last method? Now we about to go into quadratic formula. If ever you're solving quadratic equations on your own, the quadratic formula will always work no matter what scenario you're given. So if you don't even feel like dealing with completing the square, then that's fine. This is after you get, once you start doing stuff on your own, I know you get the calculus, something like that, and you just want to solve it. Quadratic formula will always work. It's just that other scenarios, depending on the situation you're given, may be more favorable to you. That's why they give you all of your methods to work with. Now, when you're dealing with my math lab, if I'm not mistaken, there will be certain problems that will ask you, as you go throughout the session, not the session, but the section, solve using factoring. They may ask you something that you only would do if you're factoring, then ask you about square root property, then ask you about completing the square, then ask you about quadratic formula. Then eventually you get to the point where it'll just say solve. Then you can just solve it whatever way you want to, so Just throwing that out there because I know somebody asked that from my other class. So the quadratic formula, like I said, the last method using solving your quadratic equations, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a, where you're getting a, b, and c from your form of ax squared plus bx plus c equal to 0. Now put an arrow on that 0 because you want to set one side equal to 0 before you pick out what is a, b, or c. All right, so you can't establish what a, b, and c are to plug into the formula until you set one side equal to 0. All right, so when we look at that first one, first example, 8x squared plus 2x equal to 1. That's the first thing we come across is the fact that one side is not set equal to 0. So in other words, a is not, I can't establish that a is 8, b is c, b is 2, and then c is 1. Because you have to set one side equal to 0 first, then you'll be able to establish it, and then you'll see that at least one of our signs will be different. So when you subtract 1, ones cancel on the right, and that'll leave us with 8x squared plus 2x minus 1 equal to 0. And that allows us to see that 8 will be positive, a will be positive 8, b will be positive 2, and then c will be negative 1. And those are the values we will plug into our formula. So make sure you plug in, your values in accordingly. Make sure you're not losing a negative when you do your substitution. So we have negative 2 plus or minus the square root of 2 squared minus 4 times 8 times negative 1 over 2 times 8. So once again, all we did was plug in 8, 2, and negative 1 accordingly. All right. Any questions with the substitution? So from there, you go to simplify. Like I mentioned, that's negative 2. Then we have 2 squared, which is 4. We're under the radical right now. Then negative 4 times 8 is negative 32 times negative 1 would be positive 32. And then in the denominator, 2 times 8 is 16. So simplify what's under the radical. 4 plus 32 is 36. Square root of 36 is 6. So we have negative 2 plus or minus 6 over 16. So now that we have negative 2 and 6 in our numerator, we can go ahead and add those. So we are expected to simplify further. So there's negative 2 plus 6 over 16, negative 2 minus 6 over 16. And 4 over 16 will be 1/4. Negative 8 over 16 will be negative 1 over 2. So whenever you have answers that come out to solid numbers like that, that means that we could also have factored this if we had decided to do so. All right. Questions on the process before we do another one?
Yes, sir. Can I just scroll back up to the red section, please?
Yep. And if ever I go through this stuff, and while I'm going through it, if you need me to slow up, that's for everybody. Feel free to do so. Tell me, I don't know where you want me to go. That's good.
I'm good. Thank you.
All right, no problem. Not a problem. That's anything else before we look at another one like this? All right. So let's look at 3x squared minus 2x plus 4 equal to 0. All right, so one side is already equal to 0. So that means we're good to go on that end. A is equal to 3, B is equal to -2, C is equal to 4. So once again, it's important to make sure we don't lose a negative. And a lot of people do that with B. Whenever B is negative, a lot of times they'll drop one. So we have a minus sign sitting on the outside of B, which is a part of our formula. And we're going to plug in -2. So that's -2 in the front of that expression. Make that negative a little more dominant. And then we're going to do plus or minus square root of -2 squared minus 4 times 3 times 4 over 2 times 3. All right. So that negative to negative turns positive for that 2. So we have +2 sitting on the outside of the plus or minus. Then under the radical, we have -2 squared, which is +4. And 4 times 3 is 12. 12 times 4 is 48. And 2 times 3 is 6 on the bottom. All right. So 4 minus 48 under the radical, we get -44. So I did a little breakdown right here of the square root of -44. So you can break up that -44 into -4 times 11. Take the square root of -4 and leave the 11 under the radical. So the square root of -4 is 2i. So that'll take us here. 2 plus or minus 2i square root 11 over 6. So to finish it off, we see that, well, first of all, we have a real part and imaginary part, so we would look to break it apart. But even if we didn't, because both terms have 2 in the numerator, and then we have a 6 in the denominator, that can be reduced anyway. So that'll be 2 over 6 plus or minus 2i squared root 11 over 6. And that will reduce to 1/3 plus or minus I square root 11 over 3. All right. Questions? Any questions? All right. Very good. So I do want to start 1.6 just because things, the first part stuff we've done before. And then I'll close out. We'll close out today. Let's see, we started, this class starts at 11. Yeah. Okay. So 1.6 is other types of equations. And here we have 3x to the 4th equal to 27x squared. And so we have our highest exponent is 4. So that lets us know that we should get 4 solutions. All right, so we're going to solve this the way we would our quadratic by starting off with setting one side equal to 0. And so we can subtract 27x squared from both sides. And that'll give us 3x to the fourth minus 27x squared equal to 0. Now we can factor that. You got a chance to write before I keep going. All right, so if we factor it, we can factor out 3x squared from each term as a GCF. So that will leave you x squared minus 9 in the parentheses. Then x squared minus 9 is the difference of squares, which is what I was emphasizing over here. You know, whenever you have x squared minus y squared, you can break it down to x plus y, x minus y. So when I look at x squared minus 9, there's x squared minus 3 squared. So that breaks up into x plus 3, x minus 3. All right. So from there, you set each part equal to 0. 3x squared equal to 0, x plus 3 equal to 0, x minus 3 equal to 0. So for the 3x squared equal to 0, we divide by 3. That'll give me x squared equal to 0. Then if I were to take the square root of both sides, that would be plus or minus square root of 0. And so, see somebody in the chat, let me do this real quick. So that would actually give you two solutions right there, even though there's no such thing as a negative 0. So you don't have to write it twice, but that's where our fourth solution would end up. Yeah, no problem, no problem. You are good to go. Thanks for letting me know. So that first quantity would, or first element would actually produce two solutions that are the same, which is 0, but you only have to write it once. You know, x equal to 0, just write it one time. And then second one, x plus 3, subtract 3 from both sides. So your solution would be x equal to negative 3. And x minus 3 equal to 0, add 3 to both sides. And that would be x equal to positive 3. So those would be your 3 solutions with a repeated solution of 0. So once again, your factoring, you know, is coming into play. So make sure you get with me on it if you need a reminder or refresher. I think we have one more and then we'll be done for today. Let me check. Yeah. So questions on that one before we go to this last one? All right. So the next one, x cubed plus x squared equal to 4x plus 4. And we have a cubic equation here, so we should be getting 3 solutions. So once again, we're going to set one side equal to 0. And so I decided to take 4x and 4 to the left side. So I subtracted 4x and subtracted 4 from both sides of the equation. And that gives me x cubed plus x squared minus 4x minus 4 equal to 0. Everybody okay so far? All right, so whenever you have 4 more terms, you're going to factor by grouping. So normally, what you would do is group together the first 2 terms, group together the second two terms and see if you can factor out a GCF out of each. It doesn't have to be the same GCF, same greatest common factor, but you want to be able to factor out something. Also take notes and be careful with this because a lot of times people make this mistake. This negative that's sitting in front of the 4x cannot be separated from the 4x. Notice I put it inside the parentheses with the 4x. So you want to make sure that that minus sign stay connected to the 4x because that's not just positive 4x, that's negative 4x. Once you have a minus sign there, that's considered a negative 4x. All right. So from there, we factor out the greatest common factor from here, which is x squared. Pull it to the front. I'm left with x plus 1 in the parentheses. Then the greatest common factor from negative 4x minus 4 is negative 4. And I'm left with x plus 1 in the parentheses. So now this x plus 1 in both parentheses, in order to finish off the process, has to be the same. If I pull a GCF out of each term or each quantity and I don't have the same thing in the parentheses, I cannot move forward. So you got to make sure that is the case. So if that is the case, when you don't have the same thing in the parentheses, either go back and check your factorization, or you may want to go back to the original problem and rearrange your terms and try to do it from there. So sometimes that is the case. But what you're going to do is, now that you have x plus 1 that's in common with both, you can bring x plus 1 to the front. And then you're left with x squared minus 4. And that's what happened down here. All right. And then x squared minus 4 is another difference of squares when we talked about that with the x squared minus 9. So that breaks up into x plus 2x minus 2. And now we have factored completely. Once you've done so, you can say each part equal to 0 and solve for x. So x plus 1 equal to 0, give you x equal to negative 1. X plus 2 will give you x equal to negative 2, and x minus 2 will give you x equal to positive 2. All right, questions? Any questions? Everybody good? Everybody straight? Yep. So, with that being said, going back to what your classmate mentioned, when you have these problems, you're trying this stuff out, it's imperative that you get help on them. So you're not just, I hit you with a test and then you're like, now you want to ask questions, but now you got a test in front of you. So you don't want to wait until then. And since I give you this extra time, you don't want to wait until, the day before the test to ask the questions either, if you don't have to. So, once again, I try to give you guys room to ask questions, whether it be before or after class. Just like in this type of situation, you could ask questions. If you don't have them now, like I said, no harm, no foul, but just giving you the mindset of how you want to be attacking this stuff. When you go through your homework, if you can't figure it out, my math lab doesn't help even with that explanation. Then write it down, take a picture, do whatever, and bring it to class so we can actually go over that problem. And more than likely, your problem will help somebody else's problem. So I don't have a problem, not to overuse the word problem. Don't have a problem with, helping you guys out with whatever. Like I said, if you saw it on the test, because remember, if I give you a test that's unproctored, that you get to take, in other words, you get to take, whenever you want to, and you see a problem up there that just stumped you, before you take it the second time, if you haven't figured it out, just bring it to class. I'm not going to ask you where you got the problem from. We're just going to go over it. So, take advantage of that thought process and that mindset that I have when it comes to helping you guys out. And, let's knock this thing out. My goal is for everybody to pass. So I want you guys to be able to do so. And do whatever I can to help you guys out, aside from actually doing the problems or giving you the actual answers, on your test. Only reason I say that because I've gotten that question before. So I'm beating you to the punch. But any questions, concerns, comments before we close out? for today. This is Wednesday. So yeah, close out for the weekend. Everybody good, straight. All right. So this weekend will be a great opportunity for you guys to, take time out, try to get some problems lined up. If you come in Monday with questions, we can address them and go from there. So looking back, not looking back, but looking at what we have left. Let me make sure because I forgot whether this class goes to, not this class, but this chapter goes to 1.7 or 1.9. I mean 1.7 or 1.8. I think it's 1.7 though. 1 second. Oh, you kicked me out of my math lab. Great. Uh, all right. Homework. There we go. So yeah, so this goes to 1.7. And don't forget you have a test review there. They're not mandatory, but they will help you streamline your test studies. Let's see, did I post test one? I believe I did. Yes. So for the first test, at least you know you will have it at your disposal to take whenever you like. Let's see. So we're only going to 1.7. Let me look at some dates. And so this is the 27th. This is Wednesday.
I have a question.
31st. Yep, I'm
So
listening.
we have two attempts for the test?
Yes.
Okay.
And then also, if you have any issues with something, let's say my math lab kicked you out, or something funky happened, something weird happened, then you always let me know. I mean, resetting the test or give you another attempt is not a big deal.
Okay,
I
thank you.
know, yeah, not a problem. I know crazy thing happens. Oh, glad you mentioned that because it made me think about something else. Also, don't forget if by some chance you type in something. And when you go through your homework, also take note of how they are accepting the answers or how they want the answers. So if we go back here and you type in your answer, x equal to -1, x equal to -2, and x equal to 2, well, they wanted x equal to -1 comma -2 negative. This is what the program is looking for, but you gave it like this, then they're going to mark it wrong. So if that occurs, then you have to let me know and I can go in and adjust your score. But I won't know unless you let me know. Also, like I said, take note of that so that that doesn't have to keep happening, every single time. If you notice that that's how they want the answer, then start giving an answer like that. I know I had one student one time where I guess she just was like, I don't care. I'm going to answer whatever way I want to. And so every single test, I had to go in and adjust scores. So I would prefer not to have to do it like that. But if it does, and you just got the answer whatever way you want, but you're still getting the right answers, I will make the adjustment. But I would hope that we start to learn how my math lab want the answers. So, so just throwing that out there. So just, start to take note as to how they want the answers. The way they want the answers in the homework is the same way they're going to want the answers in the test. So if you get them 100% in the homework, and so I'm assuming you're grasping how my math lab want those answers. But once again, I understand though, test pressure, kicks in. You're not always going to be thinking exactly how, you did things in the homework. So once again, if you have an issue, after it's called syntax errors. You have syntax error, just let me know and I can adjust the score. So what you would do is just shoot me an email, say on test, could you take a look at test one, numbers, 23, 24, whatever you did, because I believe I got those right, so I'll go in and adjust the score. So just throwing it out there because I do know there are some professors who just won't do that. So I don't know what experiences you guys have had in the past, but just let you know that I will adjust the score accordingly. So it is January 27th. We are on section 16. So what, February 7th? I think would be a good date to have chapter 1 done. Because see, the thing about it is when it comes to this stuff, you don't want to leave it, just lingering out there because, one thing builds upon another thing. So you do want to get out of, chapter 1 at some point because I can't hold a lecture hostage. So at some point you do want to put yourself in position to be out of chapter 1 and going into chapter 2. So let's look at setting chapter 1's due dates for February 7th. That's a Sunday. And so whenever I set due dates, then it'll be for midnight. So once it goes over into February 8th, that deadline will cut off. So if you're working on something during, 11:58, just know you got one more minute before we'll kick you out. And I believe it kick you out, or if nothing else, when you go back into it, it won't let you go back into it. So let's set our first due date for that.
I have a
Um,
question. When
yes,
is the test due?
it will be doing that same day. So everything from chapter 1 will be due February 7th. And, if it's looking at it and we need to extend that out, then we'll see. But right now we're talking about over 2 weeks, to get all of chapter 1 done. And like I said, we're on this section 1.5, 1.6 now. So, what's supposed to be happening is that, you're doing the work as we progress. So really, being in somewhere around 1.3, 1.4 is more, where you should be. So it's not like I'm asking you to start from section 1.1 right now. You should have been doing work, and as we progress throughout the lecture. So so that's our due date. And like I said, if anything need to move, we'll talk about it. We can have a legitimate, discussion. I'm not against that at all. But right now, our due date is February 7th for all of chapter 1's content. So that includes the tests, and all the homeworks. Questions? Any questions?
I have a question.
Mhm.
I'm sure you already mentioned it. It was about the test. Is the test timed at all?
No.
Okay, that
Yeah.
was it.
Yeah, not a problem. Also, the way, I don't know if I mentioned it to this class, I don't think. Let's say if you get into the test, you know how you can go in and out of your homework. You can go in and out of your homework, submit, save, whatever, come back, pick up where you left off. Well, you can't do that with your test. So now the cheat to that is that if you get into the test and you need to walk away, you need to step away, but you don't want to leave it up because that's the last thing you want to do because you don't want, one of your children to come and hit a button and submit. And now you got a 20 or a cat come walk across the keyboard and, do something crazy like that. So what you want to do is you want to treat it as if an interruption occurred. So if you're in the middle of a test and you just need to take a break or whatever, you can just hit the X button up here. Just close it out. Don't log off. Don't hit submit. You most definitely don't want to hit submit if you're not finished. There is no save button. So you just want to close it out as if an interruption occurred. If you do that, it will let you pick up where you left off when you come back in there. So I wouldn't suggest trying that for every class that you get into that deals with my math lab or any type of Pearson product, because I know that you can adjust it so that's not the case. But just letting you know that's how my tests are set up. That if you get kicked out, then it'll let you pick up where you left off. So that's just a way you can handle that. If you step into the test, but then find out you need a break or need to step away, once again, hit the X button, just close it out, close out your whole web browser, then it'll let you pick up where you left off. All right. Any questions before we close out? All right. So you guys have a good one. Have a great weekend. Be safe, and I will see you on next class.
Thank you. Have a nice day.
Thanks. You do the same.
Thank you.
Have a good day.
All right. You do the same. Thank you.